And here's our starter for today, two short problems. And these are just two problems where I give you a vector in polar coordinates, and I want you to find the rectangular coordinates. And here I give you a vector in rectangular coordinates, and let's find the vector in polar coordinates. So let's solve. So to find a and the x, we just need to take a and multiply it by the cosine of theta. And so that's just going to be equal to 100 meters times the cosine of 195 degrees. Oh, and let's draw a picture of both of these. And when I do that, a and the x is equal to, oh, where's my calculator? What did you guys get? What did you get, Sarah?
For the x.
Huh?
For the x.
For a and the x. 6.6? 96.6? Sorry, I forgot to get my calculator ready. I'm going to depend on you guys. Okay, everybody agree with that? Oh, negative 96.6. Okay, let's hold on to that and see in just a second. A and the y is equal to a times the sine of 195. So that's 100 meters times the sine of 195 degrees. And what'd you get for a and the y? What'd you get? Negative 25.8 meters. Now, and this is, yeah, this should be negative. Now let's and you can box it like this, or you can put it like this. A equals negative 96.6 meters, comma, negative 25.8 meters. Am I still on screen? Yeah, barely. Okay, so you can put it like that, where it's in the coordinates, or you can just do this. Now, I do want you to draw a sketch of these, and it's a great way to check your work. So you just draw your XY axis, say 100 meters at 195 degrees. Well, where is 195 degrees? It's about like right there. So let's just make 100 that much. Now, I've made that angle too big, but I think you can see that the X component will be bigger than the Y component, and they should both be negative. This is a negative X, negative Y, and sure enough, that's what we got. So that makes sense. So the nice thing about drawing a very quick sketch of your vector is that you can check your work very quickly. Like if your calculator is in radians and you get a completely wacko answer, well, if you're not careful, you'll just write down that completely wacko answer and you will lose points. But if you draw a little sketch and say, is this reasonable? And you go, oh yeah, okay. And if it's reasonable, then you can be pretty sure that it's correct. So let's solve this one. Well, to figure out, I know b in the x and b in the y, so to find b, I take the square root of bx squared plus by squared. So let's plug in our values. Negative 4. Do I need to put the negative there? Not really, because it gets squared away. Plus 68 meters squared. I don't know, what is it, like 75, 76, something like that? What'd you get for B? What did you get? 81.5? Okay, a little bigger than I thought, but still within 81.5 meters. Everybody agree with that? Okay, so that's how big the vector is. That's its magnitude. Now let's figure out what its direction is. Theta equals the inverse tangent of b in the y over b in the x. So let's plug in our values. B in the y is 68 meters. B in the x is negative 45 meters. And this tells me I have to do something, doesn't it? What am I going to have to do? I'm going to have to add 180 because this negative 45 means that I'm going to be in positive 68. That means I'm going to be in the second quadrant. Your calculator cannot handle the second quadrant, so you're going to have to add 180 degrees. So this will give you a negative angle. Plus 100 degrees, it'll give you, I don't know. And what did you guys get? What did you get? Anybody get it? Are you going to make me dig for my calculator, people? Oh, here it is. What'd you get? 123.5 degrees. You guys agree with that? Okay. Now let's draw a little picture of it. Here's my XY axis. And I'm going to say, okay, B in the X is negative 45. So we'll just say, okay, there's negative 45. Now if this is negative 45, this is going to be taller. And so there's B in the X, here's B in the Y. And so my overall vector is going to be off in that direction. And let's see, does that make sense? Here's 90, 90 plus, yeah, that's about right. And the magnitude looks correct as well. It's going to be bigger than either of these. And since these are pretty close, this is going to be significantly bigger than this. All right? So the sketch really helps, people. It really does, and it doesn't take long to do. And you can really save yourself some points on a quiz or something if you draw the sketch so that you can check your work. And there you go. This is how you show your work. This is how you go from polar coordinates, where I give you a magnitude and direction, to an x and y components of the vector. And here I give you x and y components, and we find the magnitude and direction. Any questions? That is all.